This is part 3 of our lesson on solving logarithmic equations. All right, so we've taken a look at one where we rearranged, one where we factored and then rearranged, and this one is a little bit different. So I have log base 8 of 4x plus 17 equals log base 8 of 13. So my goal, as I mentioned before, is to always try to find a way to get our equation into a polynomial because that's the easiest way to solve. Now, when I look at this one, I do notice that this has something different than the previous one. The previous one had several logs, but they all had the same base, the same argument, but they had different exponents. This one, when I look at it, they have the same base, but they have different arguments. So when I have same base, different arguments, I'm probably not going to factor because I can't easily use variable replacement. I could try to use log rules, right, to break things up and try to get things with variables. But one of the methods that we can use is what we call comparing the arguments. So if you have one single log on the left and one single log on the right, and they both have the same base, that means the two sides are equal, right? So the two logs are equal. So if log base 8 of 4x plus 17 is the same thing as log base 8 of 13, it goes to reason that the arguments should be the same, right? If they have the same log, they have the same base, they're both equal, then those arguments should also be the same. So we would say that the two arguments should be equal. So 4x plus 17 should equal 13. And I only do this when I have one log on each side, no other terms, right? They have the same base, but usually different arguments. This is now a polynomial, so I can just solve. I would subtract 17 from both sides. 13 take away 17 is -4. And then I would divide both sides by 4 to get that x equals -1. Now, I do need to just check and make sure that I'm not going to get either a 0 or a negative number in my argument. Now, I don't have to worry about the 13, it's just a number, but I do need to think about the 4x plus 17. So what I'm going to do, you don't have to write it down. You can just check on your calculator, but I don't have my calculator with me. You can just take 4x plus 17, put in -1, and make sure that it doesn't give me either a 0 or a negative. So 4 times -1 is -4, plus 17 is 13. Is that a 0? No. Is that a negative? No. So that means we should be fine. I can put this back in and it will work okay. It doesn't tell me that my answer is right, but it does tell me that my answer isn't going to break my equation. Okay, we're going to take a look at the next page. So our last method that we have here is using log rules. So we learned log rules in unit number 1, we used them in unit number 2, and then here we are in unit number 3, and we are still using them. So if I take a look at this equation, I have log base 3 of 2x plus 1 equals 2 times log base 3 of 13. Now, looking at this equation, it looks very similar to the previous question, but there is one little thing that's different about it, and that is this 2, right? Right now, I can't just set the two arguments equal because there's a coefficient here that's in my way. So I want to see if there's a way that we could rewrite this so that that coefficient is not there. So one of the rules that we learned when we were talking about our log rules is that you can take an exponent, you can take a coefficient and move it up as an exponent on the argument. You also can take the exponent off the argument and make it a coefficient out front. So I'm going to say this is log base 3 of 2x plus 1. And then this is going to be log base 3 of 13 squared. 13 squared is 169. Now at this point, I see that I have two logs. They have the same base. They have different arguments, right? But there are no other terms, which means I can compare their arguments, right? If they have the same, they're both logs, they have the same base, and they're equal, that means their two arguments should also be equal. So 2x plus 1 should equal 169. I'm going to solve by rearranging now that it's a polynomial. So I have 2x equals 169, take away 1, which is 168. I know that I can rearrange because we only have one variable to solve for. And then I'm going to divide by 2, which I believe gives me 84. I'm just going to double check that number. Yep, it is 84. Okay, as we mentioned before, we do need to just check. You don't have to write your check down. You can just check on your calculator. If I was just going to check on my calculator, I would take 84 and I would do 2 times 84 plus 1 and make sure that that is not 0 and it is not a negative. Well, 84 times 2 plus 1 is 169. So that's not negative and it's not 0, which means our answer is fine. It doesn't mean my answer is correct. It just means that my answer isn't going to break my log equation. Okay, we do have one more question to attempt, but I think we're going to do it in the next video.